Alright guys, in this video I'm going to explain to you what 2's complement is and how 2's complement is important when we want to add and subtract positive and negative numbers. So what we're going to do is we're going to go ahead and fill these in. I'll do them in red here. And we'll do the binary. So 1, 0, 0. 1 is just going to be 1. 2 is 1, 0. 3 is 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. And 7 is 1, 1, 1. Okay? So for the negative numbers, we're going to represent these a little differently. What we're going to do is we are going to flip all the bits and add 1. All right? So we're going to represent all of these with 4 bits. So let's make this look a little better. Let's do 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, and 1, 0, 0, 1. No, that's not right. Hold on. 1, 1, 1, and 1, 0, 0, 0. Okay. Actually, yes, 1, 1, 1, 1, 0, and 0, 1, 1, 1. Okay, there we go. We have 1, 0 through 7. Now, what we're going to do in order to represent the negative numbers is we're going to flip the bits of each number. Like, for example, negative 1. We're going to take 0, 0, 0, 1, and we're going to flip all the bits. 1, 1, 1, 0, and then we're going to add 1. So we're going to flip all the bits, and then we're going to add 1. So this becomes 1, 1, 1, 1. So negative 1 is 1, 1, 1, 1. All right? So let's do negative 2. We're going to flip the bits. So let's go ahead and do that. Actually, we'll keep it red. All right. So if we look at 2, we have 0, 0, 1, 0. So let's flip the bits. 1, 0 becomes 1, 0 becomes 1, 1 becomes 0, 0 becomes 1, and then we'll add 1. So 1, 1, 0, 1 plus 1 becomes 1 plus 1 is 10. So we put a 1 here, we put a 0 there. 1 plus 0 is 1, 1, 1. Right? So 1 plus 1 is 2, right? So 1, 0 is 2. So we get 1, 1, 1, 0. So negative 2 is 1, 1, 1, 0. Again, when we flip the bits, that's the 1's complement. And then when we add 1, that's 2's complement. All right? So let's go ahead and do the next one. So if we look at 3, 3 is 0, 0, 1, 1. So let's do 1's complement. 1's complement means we're going to flip all the bits. 0 becomes 1, 0 becomes 1, 1 becomes 0, and 1 becomes 0. And then we'll add 1. So we get 1, 1, 0, 1. So that's 1, 1, 0, 1. Okay, let's do negative 4. So 4 is 0, 1, 0, 0. Let's flip the bits. We get 1, 0, 1, 1. And let's add 1. So 1, 0, 1, 1 plus 1. So we have 1 plus 1, right? That's 2. So 2 is 10. So put the 1 there, put the 0 there. Then we get another. 1 plus 1 is 2. Put the 1, 0. Put the 1 there. 1 plus 0 is 1, 1. So that's our 2's complement. So that's 1, 1, 0, 0. Let's go ahead and do negative 5. So 5 is 0. Again, I'm looking right here. 0, 1, 0, 1. That's 4 plus 1 is 5. Let's flip the bits. 1, 0, 1, 0. It's very easy to just add 1 here. So we get 1, 0, 1, 1. Let me go ahead and erase this. Let's get some real estate for us to finish up our chart. All right, let's do negative 6. So 6, if we're looking here, it'll be 1, 0, 0, 1 plus 1. Okay, we just want to add plus 1. So 1 plus 1, remember, is bring the 1 up here, carry the 1, bring the 0 here. Then we get 1, 0, 1. So we get 1, 0, 1, 0 for negative 6. Let's do negative 7. 0, 1, 1, 1. And negative 7 will be 1, 0, 0, 0. And we'll add 1, so we get 1, 0, 0, 1. And we could do negative 8, but we're not going to bother. Okay, so we have 2's complement. 2's complement is only used to represent the negative values. If the values aren't negative, we're going to use the regular binary numbers. So why do we do this? Let's take a look. Let's take 5 plus negative 3. So we're going to take 5 plus negative 3. So negative 3 is 1, 1, 0, 1. And 5 is 0, 1, 0, 1. Okay, let's add this together. So 1 plus 1 is carry the 1, put the 0 there. That's 1. 1 plus 1, carry the 1, put the 0 there. 1 plus 1 is 1, 0. Let's see here. Okay. All right, so let's see if we did this. 1, 0, 1, 0, 1. And negative 3. All right. Okay, right there. We could just disregard that bit. So we have 5 plus negative 3 yields 2. And if we look here, 1, 0, 0, 1, 0 is 2. We can just disregard this bit. Don't worry about that bit. We don't have to deal with that. In a computer, this would be a 4-bit number, so we would get rid of the 5th bit. So that works. Let's try another one. Let's try negative 7 plus 7. So negative 7 is 1, 0, 0, 1. And positive 7 is 0, 1, 1, 1. And let's go ahead and add these. 1 plus 1, put the 1 there, put the 0 there. 1 plus 1, put the 1 there, put the 0 there. 1 plus 1, put the 1 there, put the 0 there. And put 1, 0. Again, we are going to change the color here for you. We're going to chop off the 5th bit. That's not, we don't have to worry about that because we're only dealing with 4-bit numbers. And we get 0, 0, 0, 0, which is 0. So negative 7 plus 7 yields 0, which is good. That's what we want. All right. So that works. Let's try one more. Let's try negative 4 plus 1. All right. So 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 1 is 1. All right. So when we add these together, this is our answer. Okay. So again, this was negative 4 plus 1. And we get 1, 1, 0, 1, which is negative 3. So negative 4 plus 1 is negative 3, so it works. So the reason why we do 2's complement is to allow us to add positive and negative numbers together. There's other types of representation. There's 1's complement, where we just flip the bits. And then there's having a sign bit, which is terrible. I'm not even teaching that because that doesn't work, so we're not going to do that. So again, 2's complement is just a matter of flipping the bits and adding 1. And then when we add our values, if we end up with a 5th bit, we just get rid of that bit and we take the first 4 bits and we find our answer. All right, so that's how to create numbers create negative numbers using 2's complement, and we went over how to add and subtract numbers using binary numbers using 2's complement.